Thanks, Humi, and welcome everybody to Machine Learning Analytics for the Rest of Us. And I just want to call out this "for the rest of us" term, because the idea here is that we're going to look at tools today which you do not need to be a machine learning practitioner to use. We're going to put the power of machine learning in your hands without you needing to be an expert. And we'll have a look at how we do that. So this really ties into our mission at AWS, which is, we call out, to put machine learning in the hands of all developers. So sure, there will be times when deep custom models are required. We understand that. But we also want to highlight there's going to be a lot of use cases where you can just use our pre-trained models and get immediate benefits from those. There's also some cases where you do need a deep custom model, and what we've done is we've created services with wrappers to make it extremely easy to consume them and build custom models without having that deep machine learning experience. And indeed, here's just some of the customers utilising machine learning on AWS to improve their customer and citizen outcomes. And as we go through the pack today, we'll call some of these out as we go. So we're going to have two broad categories today. So the first category is how can we, it's essentially analytics, but beyond the general scope of analytics. How can we use machine learning to look at information that is perhaps got trapped data in it and pull that data out? So it could be images or videos, and we want to pull information out of those videos to increase our searchability. Or it could be scanned archives. We'll have a look at two examples in this section. So the first tool I want to run you through is called Amazon Recognition. And as it says up here, it can identify objects, scenes, text, and so on out of images or videos. It's also got incredible facial recognition capabilities. And in fact, it's capable of recognizing thousands of different types of content in images or video. In fact, if we look at quite a specific use case, we see C-SPAN in the US, who capture many, many hours of government footage every day, who used to have human beings go through that footage to catalogue who was in each video, at what timestamps did they appear. They now use recognition to handle that for them. And today we're going to look at a really specific use case that I get asked about a bit, which is detecting objects in images, and we're going to look at detecting vehicles. And we're going to take that a little bit further to say, well, let's read the license plate of the most prominent vehicle in an image. And now, in the past, this would have been a really daunting prospect to a developer. Today, let's see how we go with just 2 API calls to the recognition service. So here's the use case, and this is actually my car. And I want to highlight that this is a fairly low-res image. So again, the first thing I want to do is identify all vehicles, work out which vehicle is the most prominent in this image, and then read the license plate of that image. So before we dive into some pseudocode, I just want to show you a demo in the console, because with recognition, whilst you would normally use recognition using API calls, you can go into the console and see if this is the right tool for you, just with a quick demo. So if we switch over to the demo now, let's have a look at what recognition looks like in the console. And you can click on the Try Demo button. There's a sample image here, but I'm going to upload my own image, and it's the one we were just looking at. So you can imagine you can do this with your image. See what recognition finds. See if this is the right tool for you before you write a single line of code. So recognition has found a whole lot of information. It's confident this image is about transportation. It's got cars in it. And if we go and look at this response section here, when you call the API, this is what you'll get back. Now, don't worry too much about what you see here, because I know that text is small. But what I'm highlighting is that for each car it finds, it's labelled car, and it gives us bounding box information for that car. So let's see how we can use that information. Also in the demo, I'm just doing object and scene detection, but you can see there's a lot of other demos here, such as text and image. Have a look at that a bit later. Okay, if we can flick back to the presentation, please. Okay, so here's the API call, some pseudocode for the API call. So I'm going to call recognition, and I'm using the detect labels method. I'll pass my image into that, and I get a bunch of information returned, the same as what we saw in the console. I can parse that and say, only show me labels where the name is car, and that's the code that you use to do it. When I get that back, I can find each car, and remember I get the bounding box information, which I can actually use to plot that on top of that image, as I've done here. So, which is the most prominent car? Well, this is actually very simple maths. So, as we saw, that bounding box information includes width and height. And as we all know, area equals width times height. So with the simple mathematical calculation, I can determine which is the most prominent car in that image. So now, let's move on. How do I read license plate information? And I just want to make one API call. So in this case, what we do is we use recognition again. I've cropped out that image of the most prominent vehicle and passed that back into recognition as a new image. And this time I'm calling the detect text method. What this will do is detect any text in that image. So there will be a little bit of work for you to do because, as you can see, this is a Victorian license plate. So recognition detect text will return the number plate numbers. It will also return Victoria, the education state. It could even return Ford. So you've got a little bit of work to do there to parse out the relevant information. But as you can see, 99% of the heavy lifting in detecting objects and pulling the text off those objects is done for you. And we've done it with just 2 calls to Recognition API. Let's have a look at a different demonstration now. So in this case, I want to talk about customers and government organisations who've got archived information. A very common format for this is microfiche. So I have customers talking to me a bit about how can we get that information out of our microfiche scanned documents. So Amazon Textract is the tool for you. And again, no machine learning experience is required to use this incredibly powerful machine learning tool. So data is trapped in these scanned images. It's not too hard to go and get the microfiche converted to a digital scan, but how do you pull that data out? And you might think about traditional OCR methods, but unfortunately traditional methods really do let us down. And let's have a look at that. So here's a sample document. As you can see, this document has 2 columns. It has a table in it. Down the bottom, you can see the beginning of a graph. So traditional OCR systems do not cope very well with this. They will simply read top to bottom, left to right, and they will look for letters. Usually they don't even infer words. If they're struggling with a letter or struggling with a word, they're not looking at the words, labels, sentences, and context. So we got to thinking, how can we do better for customers? And so we've introduced Amazon Textract. And I'm going to show you a demo of this now. So if we can flick over to the demo, and a little bit like recognition, of course you're going to use API calls normally, but when you want to test if this is the right tool for you, the console is a great place to go and try out a demo. So here's what the Textract console looks like, and I'm going to upload my own document. So while this is uploading, Textract is going and analysing this. And it's going to understand not just where the letters are, not just where the words are, but it's going to, it'll give us that bounding box information that we can use to infer the columns. And it's also going to use natural language processing to infer what unknown letters could be based on the words they're in. So indeed, as we can see, it's returned all the information in this document. It's given us location information that we can use to produce those columns. And a real highlight here, if we look at tables, it's understood that it's seen a table in that document, and it's returned table information, bounding box information, all the information we need to digitally reconstruct that table in a digital version of this document. And Textract can do even more for us. And to show you that, could we please switch back to the presentation? So we saw Textract read through, understand the position of text, so we can reconstruct those columns. It understood the table and constructed that table for us and returned the information so that we can digitally create that. But it goes even further than that. If your form looks like this, and you've got a lot of key value pairs in here, such as name, address, ID, and so on, these are key value pairs. And Textract will go through and find these. So it will say, it will return you a key value pair. Name is Elvis Presley, address, so on. And it's not dependent on what the form looks like. So if your form is a bit different, then no problem. Textract will just continue working and reading out those key value pairs and returning them to you in an API form. So Textract is incredibly powerful. If you've got scanned documents that are on microfiche or another format that you need to digitally reconstruct to make them searchable, this is the tool for you. So let's move on to section 2. In this case, we're going to look at more analytics, but we're going to use machine learning to help us to go beyond the standard, go beyond the capabilities of basic analytics. We're going to look at, you've already got your data, how can we gain more insights from this data to improve our customer or citizen experience? So the first tool we're going to look at today is called Amazon Personalize, and this is a recommendation engine service. Now, at Amazon, we've been building recommendations for over 2 decades now. We've got a lot of experience with recommendation engines, and we got to thinking, how can we put the power of recommendation engines in your hands, but not require you to have any machine learning experience to build a custom model on your custom data, a specific custom model for you? How can we get you to do that? So when you build a recommendation engine, one of the complex parts is there's no one algorithm that fits all custom data use cases. What you're typically going to do if you're a machine learning scientist is try a whole bunch of different algorithms and see which one works. And that's a lot of heavy lifting. So we got to thinking, how can we make this easier for you with no machine learning knowledge? So this is how Amazon Personalize works. Well, all we do is we ask you to provide 2 or 3 pieces of information. So we ask you to provide an activity stream. So who interacted with what product? So this could be purchasing. It could be perhaps borrowing library books. In that case, the product is the library book. It could be interacting with forms on your website. Who's downloaded which information? And based on that, what other information might they be interested in? We ask you to provide details of that inventory. So give us a product code and then tell us what that product code refers to. What inventory item is it? And optionally, but preferred, if you can provide some extra demographic information about the users who are interacting with those products, that can help us actually produce even better recommendations by finding like customers. That's all you need to provide. Personalize takes that in, it puts that data in the format it needs for each of its machine learning algorithms, and it will load them and try a whole bunch of different machine learning algorithms. It will find out which algorithm produces the best results based on your specific custom data. It will then stand up an endpoint which you can make API calls against. So when you've got users returning and perhaps borrowing library books or interacting with your data, whatever it is, you can make a call to the endpoint with that user ID and find some recommendations for them based on their previous interactions and based on what other like people have been doing. So again, I want to highlight, no machine learning knowledge is required for you to build a world-class recommendation engine. And indeed, we've seen customers like Domino's right here in Australia do this. Domino's Pizza currently use Personalize to predict purchasing behaviour of their customers. They apply that context about individual customers and circumstances to deliver personalised promotions and notifications to those customers. Let's look at a similar service. So this is Amazon Forecast. So again, you can imagine at Amazon, we've been doing supply chain forecasting for many, many years. We've got really good at it, we have to be. But what we now want to do is take all that knowledge we've got, package it up and put it in your hands. And we want you to be able to use this without machine learning experience. So let's have a look at some of the challenges in time series or supply chain forecasting. So imagine if you're forecasting products on the shelf. If you forecast too high, then you're going to end up with unsold products and wastage. If you're forecasting staff levels required, then you're going to end up with too many staff. But if you forecast too low, then you're going to end up with dissatisfied customers or citizens, as you are unable to fulfill their needs. An additional problem with forecasts is sometimes it's not just one data series. Sometimes there's a whole lot of related data series that impact what you're forecasting on. So let's say you're predicting the output of a solar panel. That could depend on the temperature of the day. It could depend on cloud cover. If you're predicting how customers or citizens are going to interact with your products, it might depend on whether you've done a marketing campaign or whether your competitors are doing marketing campaigns. So there's going to be some related time series you need to build in. Additionally to this, let's say you're predicting the power usage of individual customers' meters. Well, you're not just going to build a model for 1 meter. You need a model that can apply and generalize over hundreds or thousands of users' power meters. And for this reason, forecasting is quite difficult, and that's why we wanted to make it really easy for you with the Amazon Forecast service. So really similar to Personalize, we just ask you to provide your data. So your historical data, so let's say it was power meters, provide the time series data for all those power meters over their historical usage. Or if it was staffing levels, provide the history of what staffing levels you needed. Then provide some related data. So if you find that the weather impacts your forecast, then provide the historical weather and the forecast for the weather moving forwards through the period you want to forecast on, and any other related time series data. Forecast will take your data in, it will try a whole bunch of different machine learning models to find the best model for your specific custom data. Once it's found the best model, it will stand up an endpoint and allow you to call that as a simple API. So these two tools are incredibly powerful. I just want to highlight again, these are custom models that are being built and delivered for you, and you need no machine learning experience to use these. So Forecast is currently in preview. I do encourage you to have a look. You can sign up today. And indeed, we've seen customers like Mercado Libre already use Forecast to predict demand for over 50,000 products. Okay, so we'll move forwards to data visualization and some ML insights we've built into this. So some of you may have heard of Amazon QuickSight. It's been around for quite a few years now. It's cloud-powered business intelligence software, and it's enabled many, many customers to visualize their data, analyze, report, and gain great data insights. And the key here is at extremely low costs. So there are some very, very powerful business intelligence tools around, but we find licensing costs can mean that these are out of reach of many customers, or they need to be very limited in their use. Rio Tinto, for example, have created a lot of dashboards for critical risk management systems using QuickSight. And what it allows them to do, because of the extremely low cost, is scale these dashboards to more end users and only pay for what they use. But what QuickSight's recently done this year is introduced some machine learning capabilities built in. It's introduced anomaly detection. Forecasting. Not quite as deep as the forecast tool we just looked at, but if you've got simple forecasting requirements, this is a very, very easy way to consume machine learning. And also auto narratives, which can look at the changes in your data, perhaps look at those anomalies, and help you build a story around that automatically. So we're going to have a look at a bit of a demo of this, but before we switch over, I just want to show you the sample data I'm going to load up and demonstrate. So this is just a sample of it. There's a lot more data than this, but I've got those 4 columns. It's time series data because we've got a date, we've got a product category, geo, and revenue. So if we could flick over to the demonstration, please, we'll have a bit of a play with QuickSight Machine Learning Insights. So I've loaded my data up into QuickSight, and this is what it looks like. So I'm just going to add a few visuals here. So in QuickSight, if I hold down the Shift key, I can select the fields I want to visualize. So in this case, I've selected revenue over time, and indeed, here's the graph. I can slide in and out to highlight the period I really want to look at. So that's not a bad view. Just for the sake of it, let's add a few more visuals. So I'm going to add, say, revenue by geography. Again, just holding down the Shift key while I select the relevant parameters I want to visualize. And QuickSight will determine automatically the best graph for that. If I don't like that, I can certainly override and choose a different type of view. And why not add a few more visuals? Let's add one which is revenue by product category. And I'm also going to add a more complex visual here. And in this one, I'm going to add more than 2 fields. So I'm going to add all of my fields. So again, I'm just holding down the Shift key while I select all of these fields. And I'm going to make this a bit bigger. So what QuickSight's done, because I've selected more than 2 fields, is it's created a pivot table. So that can be very useful. I can collapse certain fields here and get summaries of those. But the challenge is, how do you gain insights from looking at this pivot table? There could be a lot of work for a human being to operate over that. So how can QuickSight ML Insights help? And this is where we've introduced this button on the left here called Insights. So if I select this, we're instantly given insights over our data. So we've got the top 3 geos, the top 3 product categories. If I select a different view, it will scroll to the insights related to that view. Perhaps growth rate is particularly important to me. I can select growth rate, and it's going to actually highlight that on the graph to pull it out. You can see it's produced some natural language around these insights. I can add these to my dashboard if I like. And I can even modify those and use operators to perhaps make text red or green or so on based on what we're seeing. All right, so we've looked at a few insights. These are reasonably basic. What if I wanted to do deep anomaly detection? So I'll select, first of all, the view with all of my data in it, and I'm going to click on this button here, which is Add Anomaly to Sheet. So we've got a window now for anomaly detection. Now, as you can see in these field wells up the top, I'm just going to expand these field wells. It's pulled in all 4 fields, and that's absolutely fine. But because I'm demonstrating to you today and I want this demonstration to run reasonably quickly, I'm actually going to remove one of these categories. But you certainly don't need to. QuickSight just takes a little bit longer the more categories you've got and the more data you're creating insights over. So we'll click on Get Started. And this is where we can configure our anomaly detection. So I'm detecting anomalies over geography, so I might just give it a name. Anomaly detection by geo. The fields to analyse. Now, I had 1 date field, 1 value field, and 1 category. That's the minimum you need. But I could have had more. And if I had more categories, it may very well be relevant to click this box here to analyse combinations. So not just the individual categories, but actually analyse those as combinations. Now, if your data is hierarchical, such as country and state are your 2 different data fields, you wouldn't analyse combinations because that's hierarchical data. But if not, so for example, if I was feeding in geography and product category, I'd probably tick this box. The number of anomalies to show, so we'll leave that. So the occurrence. How often do we want to run this? Because your data could be very frequently updated. So do we want to run our anomaly detection every hour? Or perhaps is just every day enough, or every week? So you can select how often this gets rerun, the schedule for running it, and contribution analysis. So my anomaly detection is running over geography, but if I get an anomaly, I'm going to say, well, break that down for me. Which product categories contributed to that anomaly in that geography? So the way I can do that is select this drop-down and select product categories there. Okay, so I've got my anomaly detection configured, and I can actually click on Run Now to run the first occurrence of that. Now, as I said, the time taken to run this anomaly detection is going to depend on the amount of data you've got and how many categories you're running anomaly detection over. Because I've limited this to 1 category, it's not going to take very long. But whilst we're waiting for that to run, let's have a look at the forecasting capability of QuickSight ML Insights. So to look at that, we're going to look at this time series graph here. So I'm going to expand this out, make it a bit bigger. As you can see with QuickSight, it's really easy to create your own custom dashboards and drop and drag things around. I'm going to go back to the Insights tab. I'll unselect that growth rate. So here's our time series data. And as you can see, it's got a 7-day seasonality. That's pretty clear to see. QuickSight will automatically detect that. You can also see there's a few anomalies. We've got a bit of a funny week here. We've got a bit of a spike here in this week. That's fine. When Amazon QuickSight runs forecasts for you, it understands that those were anomalies and doesn't include them into its calculations for your forecast. Okay, so let's run a forecast on this data. That's as simple as clicking this down arrow here and running Add Forecast. So pretty quickly, this will return a forecast. And you can immediately see we've got 14 days of forecasting. I could change this to, say, 21 days if I like. If you want to do a backwards forecast to see how the forecast goes against real data, you can do that. Perhaps let's have a look backwards for a week. The prediction interval that determines the width of those confidence bars around our orange line. The seasonality, QuickSight's really good at detecting the seasonality of your data. This has obviously got a 7-day seasonality. But if you want to change that, you can override it. And once we apply our new rules, we'll get a new version of that forecast. So now we've got 3 weeks forward, and we've got 1 week back, and we can compare that orange line to reality and see how it goes. So that's quite a useful forecast. I'm just going to modify this back to what we had earlier. So 14 days. Okay, so we've got our forecast. As we talked about, whilst there are anomalies, the forecast is going to understand those anomalies and not build them in. What if I wanted to be a bit smarter? What if I wanted to say, do a what-if analysis? Because perhaps I know that, let's pick a date here. Let's say I know that on November 22nd, there's a big deal dropping. I know that I've got, let's say there's an extra $100,000 of revenue I'm expecting to drop on that day. Well, the way I can visualize this is to select that date and click on a what-if analysis. I can run that what-if analysis for a specific date. In this case, I know the date the deal's going to drop, or I can predict that over a range. So on the November 22nd, I'm going to say, well, instead of 6,150,000, it's actually going to be 6,250,000. So I can see the dot there where that's going to sit and apply my changes. And now what we're going to see is 2 forecasts. We're going to see our base forecast, and we're going to see our what-if analysis forecast. And if you drag your cursor over to a particular date, you'll see with both forecasts, you can see what the predicted revenue is for that. Okay, so we've had a look at time series forecasting and what-if analysis. Let's see how our anomaly detection's going. Okay, great, so that's finished. It's brought up immediately our top anomaly, which is Malaysia. But let's have a deeper look at this. So what I can do is I can select the down arrow in the top right-hand corner and click on Explore Anomalies. This can be a really great tool for your people to go and explore and understand what's going on. So indeed, we look at Malaysia's data and see that, yep, it was quite smooth and we had this dip here on November 14. So that was great to call out. It would have been very hard for us to see that in that pivot table, but QuickSight's called that out. And remember we talked about the contribution analysis? So what product categories contributed to that dip? And we can see that the biggest contribution was from sales of office supplies. It contributed 53% of that dip in predictions, in predicted sales. But that's not the only anomaly. So if we can show anomalies by date, we can see that there were quite a lot of anomalies back here on July the 1st. And here's all the anomalies. So let's select, say, this one here, October 1st, October 1st, 2018. Okay, so I've got 3 anomalies here. So 1 in India, Australia and Turkey. Let's say I select the Turkey region, and indeed it says, well, here's the breakdown of why it believes that that was an anomalous reading. Okay, so if we could please switch back to the presentation. I hope what you've seen today is that we've got machine learning tools available to you without you needing machine learning knowledge to extract data from where it was otherwise trapped in images and scanned documents, and to produce forecasts or recommendation engines or anomaly detection on that data, again without any machine learning knowledge required. So the story doesn't end here. I'd like to thank you for your time and ask that if anything you've seen here is of interest, please grab your Amazon team and talk to them about how you could apply these techniques to your data without machine learning expertise. If you scan your badge on the way out, you will receive this slide pack if any of this was something you want to take home. We do ask that you complete the session survey. It really helps us understand if this is the sort of content you want to see more of, or if you'd like to see something different. Thank you very much for your time.